This video is intended as a review for Milton Union High School students on using orbital notation. It's assumed that they've been in class and they've seen this drawn out. So any application to anybody not from Milton Union watching this, it's not supposed to be educational in that regard, but more of a review. My intention is to go quick, and I'm going to be highlighting some orbital notation, and every once in a while I will talk about electron configuration notation as we go through. I'm going to start with hydrogen, and we're going to build up from hydrogen and eventually get into some D block and learn how to deal with that. So at Milton Union, the way I teach you to do this is the first thing I want to see is atomic number written down. So we're starting with atomic number 1, and I want you to write the symbol hydrogen. And since we're in the first row, we write down our first principal quantum number, shell 1. We're in S block, and S has one spatial orientation, so you write one line, and you represent the electron like so. When we get to helium, He, we're still in the first row, so that's principal quantum number 1. We're still S shape. It has one spatial orientation, so I show one line. It has a second electron, so I have two arrows, and it's going to fill the shell. And remember, the arrows have to be opposite spins. Orbital notation is nice because you can see all four quantum numbers represented. You have the principal quantum number, you have the shape, you have the orbital, and you have the arrows for spin. So you're showing all of those there. When you get to lithium, lithium is atomic number 3. So you write down a 3, symbol Li. It's going to fill up just like helium did. So basically we just copy what we have down. The first two electrons go on first shell. They are up and down. Now lithium on the periodic table is in row 2. It is an S block. So again, we have S electrons, and lithium looks like this. We go on to atomic number 4, beryllium. Be, copy down what lithium had, 1s, 2, 2s. This is lithium, so beryllium will fill that shell, and it'll look like that. Notice that the number of arrows is equal to the atomic number. So arrow here, oops, guess I can't show a pointer on here. So we have an arrow with the two, S has 2 arrows, and the arrows on 1s are 2 more, so 2 plus 2 is a total of 4. Electron configuration, I will write down as an aside. I'm going to write it similar. The difference between them is instead of showing the orbitals as the lines, you just write down how many electrons are in each shell. So that would be 1s2, 2s2. All right, we're going to move on now to atomic number 5, boron. We have the same thing that beryllium did, 1s2, 2s2. Now we move over to the P block. We're still in row 2, so we have 2. P's have 3 spatial orientations, so you get 3 lines, 3 orbitals. Each orbital is going to hold 2 electrons, and boron is going to fill the electron just like that. Atomic number 6 is carbon, and this is going to be our first trick here, the first special rule. It gets copied just like boron does, 1s2, 2s2, 2, 3 orbitals for P block. Boron look like this. So where does that electron go? Some people say, well, it goes on the same line. The first one, it's a downspin. That's not true. The rule here is that every orientation, every line, every orbital must get 1 electron before you're allowed to pair them up. So in reality, the next electron goes on that line right there. Electrons naturally are repulsive, so they will spend time apart. Atomic number 7 is going to be nitrogen. It feels just like carbon does. 1s2, 2s2, 2, 3 lines, P block, and nitrogen has 3 up arrows. Now, what's nice about orbital notation is now we can have some understanding of how bonding works. And if you take a look at how many blank spots nitrogen has, it's missing electrons in these 3 spots, and it turns out nitrogen a lot of the times bonds 3 times. So you can kind of associate missing spots, like carbon is missing here, 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 and here. Carbon tends to bond 4 times. Now, it doesn't work with boron for reasons we will explain here and later on in the class. Continuing on with our notation, we'll go atomic number 8, oxygen, 1s2, 2s2, 2p. That was nitrogen. This is oxygen. And as you can see, oxygen has 2 spots, and so oxygen bonds twice. All right. That brings us to atomic number 9. Oops, I want my orange back. Atomic number 9 is fluorine. Symbol F, 1s2, 2s2, 2p, up, down, up, down, up. Notice how each line gets 1. So nitrogen, each line gets 1. Then we start the pair right here. And now we keep on pairing up. Spins have to be opposite. Lastly, we get to atomic number 10. And that's a terrible color. And let's do kind of a funky green. Atomic number 10, neon, 1s2, 2s2, 3 orientations for p, 1, 2, 1, 2, 1, 2. And it turns out neon is now filled up all of the p block. So we have 1, 2, 3, 4, 5, 6 electrons in 2p. We have 2 electrons in 2s. So 2s has 2 electrons. 2p has 6 electrons for a total in shell 2 of 8 electrons. And we have a filled outer shell, which is why neon doesn't react with anything. It has no spots to bond at. All right, we're going to take a pause on this particular one. We're going to call this one part 1. And in part 2, we're going to talk about some row 3 and some row 4.